Okay. And in this video, we will be discussing classical mechanics problems, which is asked in GATE. Okay. So here we have a first problem. F1 is equal to Q, capital Q comma Q. And it's a generating function of a canonical transformation from P, that is small p comma Q to capital P comma Q. Which one of the following relations are correct? Relations is correct. So it is correct. So we will be having only one correct answer. So F1 is a function of capital Q and small q. And for this generating function, we have to write the formulas. Okay. So small p, this is I use this as a small p, which is as this. Okay. So small p is equal to dou F1 dou Q, and capital P is equal to minus dou F1 divided by dou capital Q. Okay, so we know F1 is equal to capital Q into small q. So let's write small p, which is equal to dou F1 by Q, which is small q. So once we differentiate with respect to small q, we'll be getting capital Q. And for capital P, we'll be having minus and dou F1 by dou capital Q. So then we will be having only small q here. Once I write small p divided by capital P, we will be having capital Q divided by minus q, small q, and we will be putting minus sign here. So the answer is, so small p by capital P, which is equal to minus capital Q divided by small q. So this is the correct answer. Okay. So then, so here we have a density. So this is the problem based on Liouville's theorem. Okay, Liouville's theorem. So this is one of the most important theorem in classical and statistical mechanics. Okay, so this is the Liouville theorem based problem. And rho be the phase density of an ensemble of a system. The Hamiltonian of a system is H, which is a function of P comma Q. If A and B denotes the Poisson bracket of A and B, then dou P by dou T is equal to 0 implies. So in general, the phase density is constant. Okay, that is rho is equal to constant. Okay, so in the case of uh, ensemble systems. Okay, so once we write the Liouville theorem, the answer is straightforward. So once we write dou P, which is sorry, dP by dt is equal to dou P by dt, sorry, dou P by dou T plus Poisson bracket of rho comma h, and which is equal to 0. Okay, so once we have this, we can write from this dou p by dou t is directly proportional to Poisson bracket of rho comma h. So this is the straightforward question. So option B is the correct answer. Okay, and in this problem, that is, we have a Lagrangian given, which is L is equal to mx dot y dot and m omega square xy. If px and py denotes the generalized momenta conjugate to x and y respectively, then the canonical equations of motion. Okay, so in order to find canonical equations of motion, so first what we have to do is we can convert or we have to transfer from L to H with the help of Legendre transformation. Legendre transformation. Then we proceed. We have to find the Hamiltonian first, and L is a function of x, y, x dot, and y dot. Okay, so we have Hamiltonian as a function of x, px, y, and p. Okay, this is how we'll be having our Hamiltonian. So in order to transform this, we have to write the Legendre transformation equation, which is h is equal to p summation I pi q I dot minus n. So for this problem, we have two coordinates, which is px x dot plus py y dot minus L. Instead of L, I am using that mx dot y dot plus m omega naught square x square xy. Okay. So in order to write the Hamiltonian, we have to get rid of this generalized velocities, that is x dot and y dot, since it's a function of x and p's. Okay. So in order to find that, we just write Px is equal to dou L by dou x dot, and similarly we can write for Py is equal to dou L by dou y dot. Okay, so what is dou L by dou x dot? So here we have L here, L is given in your problem. So dou L by dou x dot is equal to my dot. And similarly, Py equal to dou L by dou y dot, which is nothing but mx dot. Okay, so y dot is equal to Px by m, and x dot is equal to Py by m. Okay, once we replace x dot and y dots in H, in this H, we are able to write the Hamiltonian in terms of P's and Q's. So here we have H is equal to Px by m plus Py by m. Just a minute. So here we have Px and we have x dot is nothing but Py by m. So this is Py and this is Px by m minus m. X dot is Py by m and y dot is Px by m and plus m omega naught square xy. So this m and this m will vanish. So we'll be having Px by m, and here also two Px by m. So I will cancel one of these terms. So I have h is equal to Px by m plus m omega naught square xy. Now we are able to find these things, find the options. So we know x dot is equal to dou h by dou px. Okay, so for this we will be having x dot is equal to dou h by dou px. Okay, so for x dot we will be having py by. So we have to differentiate h with respect to px. So once we differentiate with respect to px, we will be having py by p. Okay, so then we have y dot. Y dot is equal to dou h by dou py. So here we will be having px by m. Okay, now we will be having px dot. Px dot, which is nothing but minus dou h by dou x, which is equal to minus m omega naught square y. Once you differentiate with respect to x, that will become 1. Then we have py dot, which is equal to minus dou h by dou y, which is equal to minus m omega naught square x. So let's find these terms in this equation. So x dot is equal to py by pm. So these terms are there, and this consists of minus terms. Px dot is minus m omega square y, and py dot is minus m omega naught square x. So option C is correct. Okay. So in this video, we discussed 3 gate problems. Please share with your friends. Thank you.